Hello, everyone. Welcome back to my channel. Or if this is the first time, welcome to my channel. Today, we're going to talk about Bayes' theorem. Bayes' theorem, now this is in context with AI. First, we'll see what is the theorem, its certain special cases, and how it is implemented or how it is used in different AI fields. Okay, AI machine learning fields. So it's the fundamental theorem in probability theory and statistics. Okay. Here you compute the probability of a hypothesis or of an event given the light of a new evidence. If you come to know about a new evidence, what is the probability of the hypothesis or the second event? And it is used in many practical applications such as medical diagnostics, machine learning, as we said earlier. What's the formula? This is how it is computed. So this you read it as probability of A, the event A or hypothesis A. Again, we're going to see the example just in the next slides. Given B has occurred. Okay, so probability of A given B has occurred. So for example, probability of having a disease given the evidence that something, something in your blood report came out. Okay, probability of having or not having a disease based on the new blood report results that has come out. So the formula, it is computed as probability of B given A multiplied by probability of A divided by probability of B. Okay, where A and B are independent events. See, like your blood results are independent of the disease. Okay, I mean, the blood results are whatever it is based on whether or not you have blood results are blood results. Okay, and the disease is disease. They are independent events. That means the probability outcome of event A does not depend on the probability outcome of event B. So this theorem allows you to update your initial beliefs, okay, of the likelihood of events or hypotheses in the light of new evidence, okay, or information that you come to know. Okay. This is called as Bayesian inference, okay, which provides a robust framework for reasoning and under uncertainty. Now, there is a special case of Bayes' theorem when one of the event has a binary value, whether like true or false, happening or not happening. Okay. In such cases, it is expressed as probability of A given that B has occurred is this. Probability of B given that A has occurred multiplied by probability of A, the whole thing divided by probability of A or probability of B given that A minus. So see binary, right? So negative or positive. A minus has occurred multiplied by probability of A minus plus probability of B given A plus has occurred multiplied by probability of A plus. Again, we are going to see some examples in the next slide. So this is probability of A given that A negative has occurred and this is probability of B given A positive or A plus has occurred. And where A plus and A minus are mutually exclusive outcomes. Okay. Like both cannot come. If it's positive, negative cannot come. If it's negative, positive cannot come. Okay. So let's say you tested positive. Either you're positive or negative for say certain type of bacteria or virus or something like that. So either you're positive or you're negative. Now, this slide explains about probability ratio rule. Okay. It deals with updating probabilities based on new evidence. So let's say what we do. uh, a slight difference between Bayes' theorem and probability ratio rule. Bayes' theorem helps you calculate the probability. So let's say you're a detective, okay, and you need to find out who is the murderer, who is the suspect, okay, given the probability of Roy being guilty, given the evidence, okay. So let's say the evidence is muddy footprints. And probability ratio rule focuses on how much the evidence changes the odds of Roy being guilty. So with the new evidence being found, what are the odds that a person, we're just taking an example, Roy, is guilty or not? Okay. So how do we start? So we start with an initial guess, which is a prior probability, which could be based on certain circumstances. So let's say somebody heard Roy was arguing or got a fight into the victim. So the probability that Roy committed the crime would be higher. So that's what you start your initial guess with, okay, or initial probability. Then, based on new evidence, when you investigate, how much that probability changes. So, new evidence. So, let's say muddy footprints. You find muddy footprints and which matches to Roy. So, then that increases the initial probability that Roy is guilty. Now, factor in the alternative. Now, the alternative is how likely is this new evidence that we got, let's say muddy footprints, even if someone else committed the crime? Because it could just have happened that Roy just walked, or it was somebody else's footprint. Because see, the footprint just matches his, doesn't mean it's his footprints. Okay. Then update your guess based on this knowledge. Okay, that is the posterior probability. So prior probability, we just guessed whether somebody is guilty of the murder or of committing the crime. Then we gather the evidence, we study the evidence, and based on the evidence, update the probability. Okay, that based on the new evidence, how likely it is that somebody is guilty, not guilty, or it could be anything else. Okay. So the formula it is how it says new odds is equal to old odds, which is the initial one, multiplied by the likelihood ratio. Okay. So the likelihood ratio is how much more likely the evidence of Roy is guilty compared to somebody else being guilty. Okay. If the ratio is high, then the evidence strongly suggests that Roy is guilty. Okay. And if it's close to 1, the evidence is not very informative. Okay. So in simpler terms, Bayes' theorem gives you the final answer, whether it's guilty or not, given the evidence, while probability ratio explains how much evidence changes your mind about the guilt or likelihood of an event in general terms. So this is the probability ratio rule. There is odds ratio rule. And this is how it's computed. This is the hypothesis given the event. Okay, odds ratio of the hypothesis given the event has occurred. Okay, so this ratio rule helps you understand the relationship between two events. Okay, just the relation, how it affects. Okay, so like exposure to something and getting a certain outcome. Say, for example, you were exposed to somebody having the COVID virus. What's the likelihood that you will get the virus too, or you will get infected with the virus too? Okay. Or another example, let's say your outcome, having a heart disease, given the exposure that you're regularly exercising. So it's just you study the relationship between the two events. It's not one is causing the other, but how does one affect the other? Okay. So how much, so let's say we want to do a study. How much more likely are people who exercise regularly get heart diseases? So it's not proven that regular heart exercising will cure heart diseases. But what is the likelihood of somebody having a heart disease given the exposure or given the fact that they are exercising regularly? So We track a group of people who exercise regularly, which are exposed. That's one event, evidence. And the other group who don't exercise. Then we record how many people in each group develop the heart disease, which is the event. Okay. So calculate the odds ratio is we analyze the data to see how common heart disease is in each group. Okay. Exercises versus non-exercises. So the odds ratio will tell us that if the odds is greater than 1, then the people who exercise regularly are likely to develop heart disease compared to those who don't. Okay. And if the odd ratio is equal to 1, then there is no difference, which means that the exercise doesn't seem to affect getting the chance of heart disease. Okay. And if the ratio is less than 1, then it does not affect. Okay. That the exercise might, it would suggest that exercise might be associated with the higher risk of heart disease. Okay. Again, see, this might not happen, but it's just a hypothesis, like what you would conclude based on the value, based on the probability value. Okay. So see, it does not prove that exercise causes increase or decrease in heart disease. It just shows the relationship between the two. So that's the odd ratio rules. Now, this is used heavily in machine learning. Okay. So, like classifying emails, whether it's a spam or not spam. So, email classifier uses the Bayes theorem. So, based on the evidence, like the new email which comes in, and certain, let's say, when you mark an email as a spam, so it tries to figure it out. Oh, okay, whether it's the from address or certain words that's been used in the email, which is used to classify the email as spam or not spam. Okay. Then updating beliefs as a new data arrives. So let's say initially you did not know a certain email was spam and you got it in your inbox and you marked it as spam. So that's the new evidence that it arrives. And then it will use again this new evidence also for future classification purposes. Okay, so that in future, if you allow or if you get an email in your inbox, whether it's spam or not spam. This allows it to continuously learn and improve its accuracy. Okay, so there are some applications in machine learning, naive Bayes classification, Bayesian network, spam filtering. These are some of the fields where Bayes theorem is applicable or used heavily in machine learning. Okay, so this all goes into the code and you code it in your model or in your Python code or whichever language you're using, and then you decide the probability, okay, whether something is true or not true based on the new evidence. So that is all Bayes theorem is all about. Okay. Thank you for your time. In next lecture, we will talk about some other machine learning concept, algorithm, something new. All right. Thank you. See you all again next time. Bye.